Bill Gates, How to Avoid a Climate Disaster, a detailed review and critique. 51 billion tons. That is how much CO2 equivalent the world emits every year, and Bill Gates is out to make every single ton go away. This video reviews his new book outlining his exhaustive assessment of the many challenges we face getting the world to net zero carbon emissions by 2050. This is a book report style review where I summarize his conclusions chapter by chapter, occasionally supplementing his narrative with data from other sources. I know, sounds snoozy, but Gates will scare you awake. I chime in at the end of the video, basically agreeing with his assessment of how hard getting to zero is going to be. However, I disagree with Gates' path forward, and looking at his long list of obstacles and technical challenges, argue that we should allocate our limited money and resources in a more practical and focused manner rather than proceeding in a panic to do it all right now, the cost be damned. Before I get into the book, let me say a few things about Gates. Conspiracy theorists imply, among other things, that he wants to put computer chips in vaccines so that his new world order can control the masses. Whatever. To be clear, he is very involved in world issues, and through the Gates Foundation is trying to enhance healthcare and reduce extreme poverty across the globe. He certainly sees climate change as a world problem that will require cooperation across all nations to address. While I certainly don't agree with every position he takes, I admire Gates for his world vision, and more importantly, that he puts his money and time and effort where his mouth is, whether it is trying to eradicate malaria in sub-Saharan Africa or designing the next generation nuclear plant. I also admire that he doesn't just parrot the emotionally driven environmental party line, so to speak, but really works to understand the situation and generally has math and reason to back up his position. In this book in particular, he looks at every single source of emissions, not all of them from fossil fuels, and he doesn't sugarcoat the extreme challenges of making those emissions go away. He acknowledges that energy is good, that to bring people out of poverty across the globe will require much more energy use, and that fossil fuels will continue to be a necessary energy resource as we transition to a zero carbon world. In his first chapter, Why Zero?, Gates only briefly discusses the correlation between atmospheric CO2 concentrations and warmer global temperatures, perhaps relying on the assumption that 97% of people are already convinced man is the cause. Well, not some of the people I know. I have many intelligent friends who have looked deeply at the evidence and, given the many complex variables that affect the climate, remain unconvinced that an increase in CO2 from 0.03% to 0.04% in the atmosphere is the primary variable driving climate change, regardless of what may happen in some complex computer model when they tweak a small mathematical knob. The bottom line is that, like many other social and political debates that are dividing our nation, both sides of the climate change argument tend to righteously cling to the evidence that supports their position while discounting any evidence to the contrary. I find myself in the middle, where yes, I do believe the evidence indicating man's emissions are having an impact, but I also believe the evidence that there are many other complex factors and feedback loops affecting the climate. And in the end, man's influence on the climate, and in particular our ability to control the climate, may be far less than we think. Therefore, I feel the prudent path forward would be to move to address our emissions, but in a rational, focused manner, such that we don't devastate our economy or bankrupt future generations. Perhaps after watching this video, you will join my voice here in the middle. For more information regarding the evidence for and against man-caused climate change, please watch my YouTube video, Weighing the Evidence of Climate Change, a fact-based case for a rational path forward. Gates' second chapter is, This Will Be Hard. In Gates' words, we can't solve a problem like climate change without an honest accounting of the obstacles we need to overcome. We will get into the challenges and technical breakthroughs needed when we talk about the various sources of emissions. But on a global scale, changing the way we provide energy will be difficult for the following reasons. Number one, fossil fuels are pervasive. Anything made with steel or cement or plastic was made by and with fossil fuels and transported to you using fossil fuels. As Gates says, when you're using any product in that kind of volume, you can't simply stop overnight. Number two, fossil fuels are cheap, reliable, and easy to use, with gasoline costing about the same per gallon as milk. As evidenced by California's high electricity costs for their high mix of carbon-free energy, the challenge will be making the carbon-free approach as cheap, as convenient, and as reliable as the current technology. Number three, world energy use is going nowhere but up, primarily in the developing world as their standard of living improves. And the cheapest and most reliable available energy in the developing world is fossil fuels. Number four, we don't currently have the answer. I don't buy the notion, says Gates, that with solar, wind, and hydro, we have all the answers needed to address climate change. We have some of what we need, but far from all of it. Number 5, society tolerates very little risk. We demand reliable electricity and have a low tolerance for accidents. Number 6, there isn't as much consensus as you may think. Even someone who believes in climate change may not buy the idea that we should be investing large amounts of money into the technological breakthroughs needed to deal with it. In regard to the level of government intervention that Gates recommends at the end of his book, I count myself in that camp. As I will summarize at the end of this video, I think our efforts should be more focused. Surely there's a limit to how much money the government can print. And number 7, addressing climate change will require global cooperation beyond that which has ever happened before. That will require a consensus that doesn't currently exist, not just that there is a problem, but what to do about it and by whom. Gates next talks about the various sources of emissions. If you think the social and political challenges look daunting, they pale in comparison to the technical challenges of addressing the emissions themselves. Carbon emissions come from 5 major categories: electricity generation, 27%, manufacturing, 31%, food production, 19%, transportation, 16%, and heating and cooling, 7%. Please note that the production of fossil fuels is not the root of the problem, as it directly contributes only a small portion of the manufacturing emissions. And as you will learn, many emissions have nothing to do with fossil fuels whatsoever. Therefore, the answer is not to ban the production of fossil fuels, but instead to reduce their consumption. To summarize, Gates' ultimate solution is to, number 1, electrify everything we can, number 2, generate that electricity from carbon-free sources, and number 3, use carbon capture to address the remnant emissions. Sounds simple enough, but the devil and a bunch of his demon buddies are in the details. The first source of emissions is electricity generation, which generates 27% of 51 billion tons. With Gates' plan revolving around a 100% electric world, electricity is the key. Even though electricity is not the largest source of greenhouse gases, Gates says, figuring out how to generate cheap, reliable electricity without emissions is the single most important thing we must do to avoid a climate disaster. So let's look at the challenges and opportunities of various carbon-free energy sources. Wind and solar. Wind and solar are the poster children of the green energy movement. While the world could use significantly more wind and solar, Gates points out some serious drawbacks that limit their ultimate share of the market. The most challenging of those is the curse of intermittency. The first form of intermittency is the difference between day and night. As a result, they have a capacity factor of approximately 25% for solar and up to 35% for wind. That means that if a city requires 1 gigawatt of power over a 24-hour period, 1 gigawatt of solar, for example, would only provide 25% of what is needed, with the other 75% having to come from backup generation sources. If you wanted to provide 100% of the energy with solar, then you would have to build 4 gigawatts of capacity that would run 25% of the time, requiring batteries or some other storage system to store 75% of the energy to use when the generation is offline. As will be discussed later, that is not even close to feasible with current technology. The second form of intermittency is the difference between summer and winter, particularly for solar. Germany, for example, uses a lot of solar, but solar output is 90% higher in the summer than the winter because of the tilt of the Earth and the length of the days. Storage can't currently solve that problem, only backup generation can. The final form of intermittency is related to extreme weather events lasting several days, where wind and solar may not be available at all. If Tokyo were hit with a typhoon that shut it down for 3 days, it would require 14 million large-scale batteries, more than the world produces in a decade, at a cost of $400 billion to store 3 days of power needs. Again, the only feasible solution would be backup generation. After intermittency, the second major obstacle of wind and solar is the amount of surface land required. Replacing a natural gas generation facility with solar could take up to 500 times the surface land, and replacing it with wind could take up to 5,000 times more surface. Even if a storage miracle occurs and it becomes technically feasible to do so, the amount of land needed for a full-scale build-out of wind and solar would be mind-numbing. The final challenge of wind and solar is the collection and transmission of the electrons. Most of the U.S. sun is in the southwest and the wind in the Great Plains, far from any major urban areas. To solve this problem, we will have to crisscross the country with thousands of miles of high-voltage power lines. But the political hurdles are considerable, as merely picking the routes, establishing the right-of-ways, and passing environmental scrutiny for a single line can be a massive undertaking. Except for the significant environmental challenges, offshore wind at least partially addresses some of these concerns. First, there's arguably plenty of space in the ocean. In addition, most major urban cities are near the coast, so transmission will be less of an issue. In that regard, Gates sees major growth potential in offshore wind. Nonetheless, as a result of these issues, there is a real physical limitation on how much wind and solar we can use. As Gates summarizes, wind and solar are not the answer to all our energy needs. They are two of the answers to some of our energy needs. Nuclear. Nuclear is the only carbon-free energy source that can reliably deliver power day and night through every season anywhere on Earth that has been proven to work on a large scale. Compared to wind and solar, nuclear uses only a fraction of the space and requires only a fraction of the cement, steel, and plastics, which have their own carbon footprint. According to Gates, the drawbacks of nuclear are A, the fear of an accident, and B, disposing of the nuclear waste. Both of these issues can be addressed. The reality is that in deaths per unit of power generated, nuclear is the safest source available, and none of those deaths have been on U.S. soil. Further, the three major nuclear accidents were all at facilities built 40 to 50 years ago. The latest nuclear design is fully automated, eliminating the possibility of human error, and is engineered so that it can't melt down based on the laws of physics. Further, it can use nuclear waste from current facilities as fuel. In Gates' words, it is hard to foresee a future where we can decarbonize our power grid affordably without using more nuclear power. Besides nuclear and wind and solar, there are a handful of other potentially low-carbon energy sources, but all of them currently have significant limitations. Geothermal. Geothermal has low energy density, still requires drilling wells, and is limited to locations where hot rocks are near the surface. Therefore, geothermal will continue to be a minor source of energy in the future. Hydropower. The environmentalists don't want to dam natural rivers, and when you do, the trees that are flooded out eventually rot, emitting lots of CO2. Therefore, it is hard to foresee any significant future growth in hydropower. Biomass. Biomass has the lowest energy density of all energy sources, and thus requires huge amounts of land. Further, the process still generates CO2 emissions. Therefore, there is limited room for growth in biomass. Nuclear fusion. Nuclear fusion, combining atoms versus splitting atoms, currently takes more energy to start the reaction than you actually get out of the fusion process. Without technological breakthroughs, nuclear fusion is not an option. Hydrogen fuel cells. Hydrogen energy, primarily in the form of fuel cells, has a lot of potential. The challenge is that the only currently economical way to capture hydrogen is from methane gas, a process that emits CO2. Research is being done on carbon-free alternatives to capturing hydrogen, but even without those, fuel cells will likely be a growing source of electric power in the future. Storing electricity. While not technically an energy source, Gates puts energy storage in the electrical generation chapter because it is an integral part of a carbon-free energy future. Of all the storage options available, lithium-ion batteries are still the best. However, there is no existing grid-scale battery storage on the planet that can do any more than help cover a few hours of evening peak demand. The problem is, lithium-ion batteries are not very energy dense, meaning it takes a lot of them to hold much energy. For example, Gates notes that gasoline is 35 times more energy dense than batteries, meaning to replace 10 gallons of gasoline weighing 60 pounds would require 2,100 pounds of batteries. That is why there are no commercial electric planes, ships, or long-haul vehicles. As far as hoping for future technological breakthroughs, Gates also points out that the laws of physics prohibit the orders of magnitude improvement in lithium-ion technology, which would be needed for long-haul transportation or grid-scale storage. The solution will require a brand new technology. Research is being done on alternative approaches to storage, but all have significant disadvantages and none are applicable on a broad basis. The bottom line is that grid-scale storage needed for a 100% wind and solar world is nowhere close to being feasible with current technology. Carbon capture. Fossil fuels combined with carbon capture are also a potential carbon-free energy source. Unfortunately, carbon capture is capital intensive. It uses a large portion of the energy generated to capture the carbon. It only captures 90% of the CO2, and that still needs to be disposed of. Direct air carbon capture is even more technically challenging because CO2 only takes up 0.042% of the atmosphere, so you need to process a lot of air to recover a meaningful volume of CO2. And finally, nobody has a good answer for what to do with the CO2 once captured, with ideas ranging from injecting it underground or trying to turn it into a salt. Nonetheless, the world will eventually need carbon capture to get to zero, because eliminating all sources of emissions will be impossible. Energy efficiencies. Gates' last subject in his chapter on generating electricity is the need to do it more efficiently. Overall, the energy system in the U.S. operates at only a 32% efficiency, where 68% of the energy consumed is lost in the process. Therefore, improving efficiency is important to reducing our energy consumption and carbon emissions. However, Gates points out that even with improved efficiencies, the world will still need more and more energy. Therefore, while producing and using that energy more efficiently is important, Gates feels it is secondary to producing that energy without emitting carbon. Emission source number 2. The next and largest source of emissions is manufacturing. We use steel, concrete, plastic, and other materials to make things that are as essential to modern life as electricity. If anything, we will be using more of them as the world population grows and gets richer. Right now, it is impossible to make these materials without CO2 emissions. Making steel requires heating iron ore to 3,000 degrees Fahrenheit, which currently can only be done using fossil fuels, although electric arc furnaces are being used to recycle steel. Manufacturing 1 ton of new steel produces 1.8 tons of carbon dioxide. Concrete is made of aggregates added to cement. The chemical process to make cement from limestone emits CO2. There is no way around it. Making 1 ton of cement emits 1 ton of CO2, plus whatever is generated in the mining and manufacturing itself. Plastics are an amazing material that are in so many products that it is impossible to list them all. They are what allow fuel-efficient cars to be so light, taking up 50% of the volume, but only 10% of the weight. All plastics contain carbon obtained from processing oil or natural gas. Right now, there is no comparable replacement. Although research is being done on multiple fronts to develop other ways to reduce the carbon emissions from manufacturing, nothing is even close to being as functional or as cost-effective as the current materials being used. As Gates states, short of shutting down these parts of the manufacturing sector, we can do nothing today to avoid these emissions. The third source of emissions is agriculture, which generates 19% of 51 billion tons. Agriculture covers everything from raising animals to growing crops to harvesting trees, and taking it to zero has many challenges. The global population is headed to 10 billion by 2100, and as the developing world gets richer, they will eat more food, particularly meat and dairy. That means more trees cleared for crops and grazing, more energy used to farm and harvest and process the food, more fertilizer, and more domestic livestock. Cattle alone right now burp and fart, as Gates puts it, 2 billion tons a year of CO2. Fertilizers are particularly challenging. They help American farmers get 5 times the food per acre than in Africa, so more will be needed in the developing world. But fertilizers require hydrogen, which primarily comes from methane, emitting CO2 as a byproduct. Further, only about 50% of the nitrogen in the fertilizers is used by the plants, with the rest going up in the air as nitrous oxides, which have 265 times the global warming potential as CO2. There are no answers to many of these emissions. Researchers are working on alternative cow feed that reduces their gassiness, tastier artificial meat, more efficient crops, more efficient fertilizers, and alternative sources for hydrogen. But as Gates states, the world isn't going to go vegan, and we aren't ever going to eliminate all the emission sources. So taking agriculture to zero will again require carbon capture. The fourth source of CO2 emissions is transportation, which generates 16% of 51 billion tons. Gates' answer to transportation is electric vehicles and/or the development of synthetic carbon-free electrofuels. Electric vehicles are currently feasible, at least where driving distances are short. However, they are less than ideal for long-distance traveling or moving heavy loads. As discussed before, gasoline is cheap and it has a very high energy content, 35 times that of a lithium-ion battery. It's the size and weight of the batteries that limit the driving distance of an electric car. These same battery limitations make it impossible at this point to have electric long-haul trucks, ships, and commercial planes. A fossil fuel-powered jetliner can fly 3 times as fast, 18 times as far, and carry 150 times as many people as the best electric plane on the market. Biofuels, such as ethanol, are not ideal replacements for gasoline. As Gates states, corn-based ethanol isn't zero carbon. Growing the crops requires fertilizer, and the refining process takes energy and produces emissions. Further, growing crops for fuel takes up land that might otherwise be used for growing food. Research is being done into synthetic electrofuels, where carbon-free electricity could be used to generate synthetic hydrogen, methane, or biodiesel. The major drawback is that they require significantly more energy to manufacture than you get out of the fuel, which is a criticism of ethanol as well. Nonetheless, Gates is optimistic that electrofuels could eventually provide part of the answer to our transportation emissions. The fifth and final source of emissions is heating and cooling. Cooling is the easier of the two because most air conditioners are already electric. Note that as the world gets richer and hotter, demand for air conditioning will grow dramatically. The problem is, current AC technology still emits some F-gases that represent 3% of U.S. emissions on a CO2 equivalent basis. Therefore, some form of carbon capture would still be required to get to zero. Heating is more of a challenge because most homes and businesses are fueled by natural gas, heating oil, or propane. The technology currently exists to use electric heat pumps instead, but the conversion will be a long, expensive process. As we close on Gates' discussion of emissions, he lists 20 different breakthroughs needed to get to net zero, from grid-scale storage to zero carbon everything to carbon capture and storage. The bottom line is that eliminating all our emissions is not close to possible with today's technology, which frankly makes the next topic even more germane. Adaptation. Before opining on what government can do to facilitate the transition, Gates touches on two other relevant topics. The first is adaptation. No matter how successful we are at getting to zero, Gates points out that we aren't going to stop global warming in its tracks. Therefore, we need to prepare for a warmer world. In that regard, he recommends that we shore up our power grids, seaports, bridges, and drinking water systems. We need to improve early warning systems for storms, and we need to plant mangrove forests to protect our shorelines. And finally, to continue to feed the world population, more research is needed in developing drought and flood-resistant crops. A more controversial topic is geoengineering, where artificial methods are used to deflect the sun's energy, such as scattering small reflective particles in the atmosphere or seeding clouds with salt spray. To be clear, Gates is not recommending geoengineering at this time, but describes it as a break glass in case of emergency kind of tool. He recognizes that it has many critics who believe it would be a massive experiment on the planet, and getting all the nations of the world on board would be problematic. But he strongly advocates continuing to study and dialogue on the subject. In his words, geoengineering is the only known way we could hope to lower the Earth's temperature in a short time frame without crippling the economy. There may come a day when we don't have a choice. Best to prepare for that day now. Gates closes his book with steps that individuals and governments can take to move to net zero. He uses the term green premiums throughout his book, which is the difference in cost of carbon-free energy and materials versus those made with carbon energy. Because most carbon-free solutions are currently more expensive, Gates feels that government needs to drive the transition, as market forces won't work on their own. Here are some of the steps that he feels government should take in terms of setting policy in that regard. Number one, dramatically increase funding for research and development in carbon-free technologies. Number two, implement a carbon tax to narrow the green premiums. Number three, create carbon-free standards for electricity, fuel, and products. Number four, work with industry from the beginning because they will be the early adopters. Number five, create incentives that lower the cost and reduce risk. Government policies should be technology neutral, benefiting all solutions, not just favored ones, predictable, as opposed to policies that sunset or are rescinded, and flexible, so that many investors can take advantage. Number six, keep policies up to date such that they don't disincentivize moves to decarbonization. For instance, most building codes don't leave room for alternatives to concrete. Number seven, build the infrastructure that will get technologies to market, such as charging stations, carbon storage, etc. And number eight, plan for a just transition, making sure to take care of the individuals and communities that will be adversely impacted by a move away from fossil fuels. As his book closes, Bill Gates sums up the enormity of the challenge of getting to zero by 2050 with the following statement. We need to accomplish something gigantic we have never done before. To do it, we need lots of breakthroughs in science and engineering. Further, we need to build a consensus that doesn't exist and create public policies to push a transition that would not happen otherwise. Now that's a mouthful. I think the only challenge he left out was where to get the trillions of dollars that will be required to implement his plan. Now that Gates is done, let me share a second opinion. I admire Gates' passion for the cause and the detail in which he has analyzed the challenge. Having said that, there are a number of inconsistencies I'd like to point out and an alternative path forward I would like to share. Number one, is 2050 a realistic date? Gates is adamant that 2050 needs to be the target date to get the entire world to a net zero carbon emissions. First, I think that is an artificial and arbitrary goal based on widely varying computer models. But even if those projections were reliable, given the multitude of needed breakthroughs, along with the social and political challenges Gates outlined early in the book, I don't think it is in any way feasible to accomplish by 2050. And I think we could shoot ourselves in the proverbial foot if we shoot for that artificial goal. Number two, will new technologies find a way? Gates has confidence that with enough money and effort, technology will find solutions, and he's willing to bet on the come in that regard. I don't share his confidence. While breakthroughs will happen on many fronts, some of the challenges have those annoying laws of chemistry, physics, and thermodynamics that get in the way, to say nothing of the math. Number three, we can't do it without carbon capture, and carbon capture in particular is a mind-numbing challenge. Capturing CO2 in substantial quantities at low cost is one problem, but what to do with the captured CO2 is even more daunting. However, if we can solve carbon capture, then all of a sudden fossil fuels are a carbon-free energy source. So if there's one future technology on which to focus, this is it. Number four, what role should wind and solar play? Gates discusses the tremendous challenges of large-scale implementation of wind and solar, but then goes on to push their deployment at every opportunity. But short of a miracle in energy storage, the math and physics say that they can only supply 25 to 35% of our energy needs, and that they will always require backup generation. Number five, nuclear is the clear answer. On this we agree. Having said that, Gates doesn't push that technology nearly as hard as he should have, given it's the only current carbon-free energy source that works anywhere, anytime at grid scale. If you are serious about addressing our CO2 emissions, then you need to get serious about supporting more nuclear. Number six, adaptation is underrated. This is an idea that even the Gates detractors should be able to get behind, because whether it's man's CO2 emissions or some other natural cause, the fact is the planet is getting warmer, and we should put serious resources toward that eventuality. And if the detractors are right, and the global warming we are seeing is due to natural causes, not our emissions, then money spent on adaptation will be the only good money spent out of this multi-trillion-dollar wish list. Number seven, to adapt, the world needs more energy. And in the developing world, that means carbon energy. The poor of the world are more worried about what's for breakfast than what's going to happen in 30 years. Cheap, reliable energy will make their lives better now, while at the same time providing them the resources needed to adapt to a changing world. Number eight, what role should government play? I concur with Gates that the transition will not occur without government intervention. Nuclear should be a full court press. Government's number one priority should be to streamline the onerous permitting process and to create incentives and opportunity for new nuclear, and to quit shutting down older plants until new ones can replace them. In regard to allocating our limited financial resources, adaptation and infrastructure should be our first priority, while research and development funding needs to be focused on those carbon-free technologies that have the best chance of success. Finally, I have serious concerns about implementing a carbon tax, as it will undoubtedly raise the cost of energy, and because everything relies on energy, the cost of all those things too. Number nine, what about the transition? To his credit, Gates doesn't push for a ban on the production of fossil fuels, which is the stance taken by most climate change alarmists. Instead, he points out the improvement in our lives that carbon energy has provided and acknowledges the reality that man will need them for decades to come. At the same time, it is somewhat surprising that he doesn't push natural gas as a fuel of choice during the transition, given the fact that more CO2 has been saved by switching to natural gas than to all wind and solar combined. In closing, I'm recommending a middle path forward, somewhere between doing nothing and the absolute panic being sold by the alarmists. In that regard, I believe man should make efforts to reduce our CO2 emissions the same as we should try to mitigate any other environmental impact we are having on the planet. But we should proceed based on facts, seeking solutions that work now, not proceeding on emotions, all the while ignoring the drawbacks of our approach. In particular, the almost religious belief that wind and solar are the answer to all our emissions is a recipe for disaster. Sure, we need to follow the science, but we also need to be doing the math and justifying the economics. But at the end of the day, man is a pretty scrappy animal, and I've no doubt we'll figure it out. So if you are worried about our murky future, remember this. It is way better than it was before we discovered carbon energy. The end. Of this video anyway, if not the debate. If you felt this video was informative, please like and subscribe to my YouTube channel, where you will find a number of other educational videos on energy. It is certainly a topic worth your effort to understand.